Today I am going to explain wind tunnel testing, including Unit 2 for Vehicle Body Engineering, 5th semester, Automobile Engineering. First, table content, scale model testing, and two force and movements. Scale model testing. Scale means, suppose if you are taking 1 meter to 1 meter, it is 1:1 scale. Suppose you are taking half meter, it is reduced scale, it is 1 meter equal to half meter. If you are taking 1 meter to 2 meter, it is double scale. It means instead of 1 meter, we will take 2 meter. This scale will be used for preparing the scale models. Suppose Maruti car is there, 10 meter long. In that small model we have to prepare. Same shape, size will be different, shape will be same. That model we have to prepare. That will be tested in the test wind test tunnel. The scale prepared model will be kept at test region as shown in the figure. Procedure in order for wind tunnel testing with scale models to be applicable to the aerodynamics of the full-scale test object. Conditions of dynamic similarity must be met. This type of means that Reynolds number of the scale model in the test and the actual vehicle in usual use should match. And if the compressibility effects are important, the Mach number should also match. Other issues students should be aware of include the possible aerodynamic interference between superstructure and model. One should always measure the drag of the support, tear or sting with no model on it first, and then subtract that from the total drag measured with the model in place. Scale model testing means small models will be tested. That will be compared to that will be applying to the real model. Next topic, force and movements. Aerodynamic lift, yaw, and pitching movement. Vertical component of the resultant of the pressure distribution is called lift. Next, streamlined body, higher velocity at the upper part and lower velocity below the vehicle. Aerodynamic lift is applied through the center of pressure of the body profile, and since its point does not correspond means coincide with the center of the gravity, it creates a pitching movement about the lateral axis. It is clearly as shown in the figure. Center of gravity is not coinciding with the pressure center. Influence of force effects on pitching. Pitching means front portion downward. Is usually small as the vertical separation between CG and CP is not great. Both lift and pitching movement have under undesirable effects, means not much effective. Lift tends to reduce the pressure between wheels and ground. These are the bad effects. Lift tends to reduce the pressure between wheels and ground. Number one, loss of steering on front wheels. Means steering stability will be reducing. Number two, loss of traction on the rear axle. Means traction will be reducing at rear side due to this effect. Pitching movement is usually negative. Nose will be down it is. Your front portion will be down. Lift force on the rear axle lifts the rear axle off the ground. Means from the ground it will be lifting, which leads to further loss of traction. The clear figure given, the dragging X, Px is there, rolling movement My is there, pitching movement My is there, airflow direction also given, lift Pz also shown vertically, yawing movement also shown Hz. And notations used for force and movements. The below table will be indicating that in that four columns are there: direction, force, movement. First one is longitudinal axis, means along x-axis, drag, force Px, formula will be Px is equal to Px rho v square A by 2. Then movement formula, rolling movement due to side force, means Mx. Mx is equal to Py Zc equal to Cmx rho v square Al by 2. And second one, lateral, means y-axis, along the y-axis, side force Py, notation is there, Py is equal to Cy rho v square A by 2. Next one, movement formula, pitching movement due to lift force My. Notation is My. My is equal to Pze is equal to Cmy rho v square A by 2. Then last one, vertical, means z-axis. In force formula, lift equal to Pz, then Pz formula is equal to Cz rho v square A by 2. Then last, yawing movement due to side force, notation is Mz. Mz formula is equal to Pye is equal to Cmz rho v square Al by 2. These are the formulas used to calculate drag forces and movement along the different axes like x-axis, y-axis and z-axis. The clear picture for side view and front view of vehicle given by the different force, and Cp and Cg also given. Mx is there, Px is there, Pz is there, Mz is there, and the Cp point is there, means pressure centrated. Then Cg also is there. Cg will be lying usually at front side. From Cp to CG distance E is there. In a front view, the Py and Ez represented, and Cp and center of gravity distance is Ze is there. And I'll explain the axis Px axis forces. Capital Px is equal to force of air drag in the direction of motion with wind along the longitudinal axis. Next one, Py means y-axis is equal to side wind force or cross wind force. Next, third one, Pz is equal to lift force. And next, capital Mx, rolling moment about longitudinal axis caused by the force Py. Then next one, My equal to pitching moment about lateral axis caused by force Pz. And last one, Mz equal to yawing moment about vertical axis caused by the force. These all are clearly shown in the figure. Then for your study purpose, some multi-choice questions I will give, just see there. Number 1, testing vehicle must be parked at test and multi-choice answers. Platform, number A, platform, number B, weaving port, number C, at end, number D, on motor. The correct answer is, for this question, platform. Means platform, it is the provided at the testing center. Next question, number 2. Tubs are used to gauge dash pattern. The multi-choice questions are viscosity, velocity, airflow, and last D, oil. Once again I will explain multi-choice questions answers. Viscosity, number A, number B, velocity, number C, airflow, number D, oil. Correct answer will be number C, airflow pattern. Next one, third question. The inside facing of the tunnel is smooth to reduce dash drag. Multi-choice answers: viscosity, number B, oil, number C, surface, number D, solid. The correct answer is surface drag. When vehicle tunnel body inside very smooth, the air forces will be reducing. That's why surface drag will be reduced. Next, fourth question. A scale model testing is used to find dash number. Multi-choice answers: number A, full, number B, Reynolds, number C, Newton, and number D, Pascal. Our correct answer is Reynolds number. Next, question number 4. Question number 5. Both lift in pitching movement have dash effects. Choice answers: good, force, undesirable, and Correct answer for this is undesirable. Thank you.